Hello everyone. So I'm going to explain what is AI and what are the stuff we are going to teach in this course, right? So myself, Sharma. So I'm the one who is going to handle this artificial intelligence. So what is artificial intelligence? So artificial intelligence is a generic intelligence systems. Other word I can say, um, I'm going to create a parallel intelligence systems parallel to the human intelligence system. I'm going to create a generic new intelligence system, which is artificial intelligence system. Like artificial intelligence system is like my long-term goal, or I can say it's my uh, like it's my target, because artificial intelligence system is a generic system which can do everything, whatever the human can do, right? The difference between artificial intelligence and human intelligence is like two. I can say the two main point is the processing speed and memory, right? So memory is the main reason or main difference between human and artificial intelligence, right? As well as like we can processing speed as well as the processing no, precision. That's a main difference between all these human and artificial intelligence. Right, okay. So as I said, artificial intelligence is my target. To achieve that, I have two different set of ways. One is machine learning, other one is deep learning. So machine learning and deep learning is the difference between these two is the difference between 5 years old and 10 years old guy, right? So the difference between the 5 years and old 10 years old guy is a thinking capacity. So the same difference is a machine learning between machine learning and deep learning, right? So in machine learning it can learn 10 future features, whereas in deep learning it can able to learn 100 features from same given set of data. And deep learning is also able to learn the variance of the. So if I'm giving some case, so I can say the classic example is, so we have 5 years old child and as well as 10 years old child. I'm for both of these guys, I'm showing a normal water bottle like Signorware, Tupperware, as well as I am showing a Whistlery water. This goes to us data set, right? And now I am asking these two guys to fetch the sports water bottle, which is not in the training data sets, right? So I have shown only Signorware, Tupperware, and normal Bisleri water bottle. But now I am asking to fetch sports water bottle, right? And now you can say the most likely the 10-year-old child can fetch the two sports bottle rather than 5 years old, because the thinking capacity. So that's a difference between machine learning and deep learning. But these two are easy to learn features, and it is able to work out or do the specific task. So whereas in machine learning depends on the method of learning, it is separate categorized into supervised learning, unsupervised learning, and reinforcement learning. And supervised learning, it's like I'm going to do some part of job for machine. Say for example, so I'm the one example is classification. So I'm going to give images as well as corresponding label. Say for example, if I'm going to classify table chair, I'm have a thousand images of table and thousand images of chair. Along with what I will do is I will create a name folder in the name of chair, and I will keep it thousand images of chair into that, and again I will create a folder of table, and I will move all these thousand images of table into that. Then the algorithm part, that like what the algorithm does is like it tries to learn what makes this thousand images chart and what makes this thousand images a table. That means it will try to extract the features from that thousand images, right? So whereas unsupervised learning, I'm not going to do this part. Instead, I will give a single folder with all these 2000 images, chart and table. I will give it to that unsupervised learning. But the first part of the machine learning algorithm is like it has to segregate these 2000 into number of groups. So if you want, you can say there are two number of group, there are three number of groups. So based on that, it will segregate that into based on some features. Okay, there are two groups are available, so I need to first it has to segregate two different groups. After that, if you are giving test image, it can able to identify which group it belongs to, right? Whereas reinforcement learning is mainly for game design. So the main concept behind this is it will randomly it will take a step. In that step, it will get either reward or penalty. So based on reward and penalty, it will update your learn methodology, right? So like any applications in the real time, it comes into this category, that is classification, regression, or clustering. And algorithms are segregated based on this. Right? In this course, we will cover we will cover this supervised learning, unsupervised learning, reinforcement learning, as well as we are teaching associative learning method. Right? So this is how the exact the machine learning scenario. It's like, as I said, we have to whether supervised or unsupervised, we have to give a training set, and from that it will learn the feature extraction. It will extract the features, and that um, feature will be learned by algorithm. Then it will create a model. Now our test data is given. It will predict that data which category it belongs to. It will give me the results, right? And this is how we normally split the data set, that is for training and testing. So we have 80% of training data set and 20% of testing data set. We will give only this 80% data set to training, and it will goes for training and all these purpose, and this 20% is for testing once this training is done. So again, as I said, like they are the maximum main classification of machine learning, and these are the typical example of supervised as well as unsupervised, like linear regression, logistic regressions, SVM, K-means, PCA. So apart from this, we are will in this course we will teach 10 more algorithms. So total we will reach minimum 15 algorithms in the real time with real time applications, and will be implemented in Python, and mostly everything is a hands-on courses. We will look into each mathematical part behind this linear regression, logic regression. Again, all the 15 algorithms we will look into mathematical part. So once the mathematical part is covered, and we will go for a implementation with the thing. So deep learning, and in this we have a deep learning, that is we are going for deep learning also, we are teaching deep learning also. So deep learning is nothing but neural network. In other way I can say it's a mimic of human intelligence system or humans learning systems based on how nucleus is learning or processing some information. So same here, hidden layer will do that stuff. So this is how the actual deep learning algorithms looks like, and we will explain all these all these what all these things are doing. But just for example, I am showing this neural networks, and this is how we normally say input layer, hidden layer, and output layer, and the functions of all these things will be clearly explained in the course once you join. And as a typical neural networks, if any real-time applications that follows this structure, this architecture, and this will the concepts of complete neural network with advanced algorithms. Right? We are teaching that also, and this is convolutional neural network, which is a most important algorithm for image processing. And if you are working or if you are interested in image processing, then you can go for deep learning methodology, and this algorithm will be useful for you. And we are the deep learning is also included in our course. And looking for tool, so we are having a set of tools. These are the set of tools will teach you, and all these are open source, and it can cover text side as well as image side, NLP side, as well as open image site, and we will teach each and every tools, and we will implement these tools with the help of Python, and we will use these tools for all those 15 algorithms. And some of the applications you can see, these are the some of the industries right now it's working on these kind of applications. And you can take, or we'll take one of the applications for our algorithm explanations. And this is how the future of the algorithms. And when comes to coding, and all these language can be used to implement artificial intelligence, but we normally prefer Python since it has a enormous amount of library support. So that's the main reasons we are going looking for Python. Or if you are good in C++, any of these languages, and you can implement your artificial intelligence with that. But Python is most preferred since it is easy language to learn and too easy to work on, as well as we have a number of libraries and a number of forums to. So, like the things we will learn is Python, as well as I said, machine learning, and in a very simplified way of deep learning. Thank you.